I had an epiphany while I was in my dining room eating dinner. And that epiphany is that we're going to get rid of these three values, and instead red will be density, green will be temperature, and blue will be composition. These. All right, so what this allows us to do is, and then so I'll be able to, like I was trying to figure out how to dynamically control this with those values, but I know you can control the particle color. So I can construct my color out of the density, temperature, composition, right? I can construct my color out of those three in that order: density, temperature, composition. Okay, and then over here, randomizer functions. Make randomizer core. Adapt to Niagara arrays. Instead of composition, temperature, and densities, color, linear color, T-star particle. What order are they in the actual randomization core? Comp, temp, dense. Comp, temp, dense. Comp, temp, dense. So it's actually flipped. So let's go ahead and undo. Okay. All right, here we go. Composition, temperature, density, all right, it goes comp, temp, dense in order. Delete these again. Back to save them all. Randomizer functions, comp, temp, dense. Come on, you slow ass motherfucker. This should allow me to get my multicolored Starfield going on. Alright, there's that. Randomizer functions, so local variables, we're going to do L comp, temp, density, right? Comp, temp, density, yep. Comp, temp density. Comp temp density. Okay. Be linear color array. We can delete this. Delete all of these. Make linear color. Comp temp density. Get. Add. Yes. Okay. And this is how we can manually control our stuff. So we have linear color array. All right, great. And now save, compile, go over here, Starfield, delete, delete, delete. Go to the Starfield, compositions, delete. 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 All right, and now color. Hang on. Delete this. CTD colors. Okay, and then back out here. Array. CTD. Okay, let's rename that. CTD colors. CTD colors. CTD colors. Star sizes still get set. Star position still gets set. Everything else gets set still. Alright, there's that. Sure. Then save, compile that. Go back to here. Linear color from array, CTD colors, array, direct set, Select vector from array. Particle ID attribute. Attribute. Well, we have different colors now. Alright, and they all need to shift white. But now we have our this thing right here. No. Fade them all slightly to white, or not slightly, this is a 50%. Yikes, it's very slow. It is kind of funny how they all jitter. We could reduce the frequency of the tick to like 1/10 of a second or something again. Okay, 0.25. Save. Oh, hey, I didn't see that people were in here. I think I'm going to be moody enough to buy a proper photo manager. Yeah, I mean, like, $15 is not that big of a deal. Like, a lot of times the stuff that I do would be easier if I just went out and bought stuff, but I kind of, like, I'm not trying to make anything, I'm just trying to learn, so I figured taking the long way isn't that bad. So play this. Do we get more color or less color? And then I'll know which direction I'm... This would appear to be more color. Let's do 0.1. Save. And multiply. So I did have some breakthroughs at the end of the session earlier. I do think that what I'm trying to do is possible, which is basically instead of having to, like, it's so hard to even put it into words. You're basically treadmilling the Starfield around the user. So say the Starfield takes up 80 million kilometers. But I want it so that when you travel 80 million kilometers, you wouldn't have traversed the entire Starfield. You would have traversed the distance between one star and the other star. Then I can take that and I can change the, like, basically the movement parameters. And I can, like, treadmill the Starfield slow, like, I can keep the Starfield pegged to where the user is, but as they move, I can treadmill the Starfield slower than the user's actually traveling. I guess that's the best way that I can come up with to put it. So, like, it moves with the user, but not quite as fast as the user's traveling, so that you can, I don't know. Okay, so this is good. What about our luminosity multiplier? I think it's too high. Let's try 10. Oh yeah, that's starting to look pretty sexy actually. Except for the vibrating. But I can probably fix the vibrating by decreasing the polling interval of moving it to like 1/10 of a second or something. Okay, so now we can do, let's do 5. Save it. And then BP Starfield. Distance scalar is at 100,000 right now. Size scalar is at 1,000. 5,000. Scan distance is at a solid 40. Star threshold at a 0.5. Let's do a 0.2. 2%. It's going to be less dense. Gonna fly to this green star here. So right now this Starfield is literally millions and millions of units across, but I'm traversing it very quickly because I have my user's motion is traversing a unit every 10,000. So look at that tiny star over there. Where'd it go? There it is. And this guy's a big boy. So, like, for instance, if I go to my blueprint here and I change these values, so like right now you can see my distance scalar is 100,000. So that is the de facto unit of measurement between individual stars. You could think of it like an astral unit for the actual world space. But then we have this value called scene units to universe unit. And right now I have this set on 100,000 or 10,000. So what this means is whatever this scalar is, it's 100,000. Every time you travel this far in the real world, you will travel through the star field a distance scalar. So like this is equal to your like actual distance between stars in the real world. This is equal to your render distance of the stars in the thing. So if I want to make my star transit faster, I could turn this into like 100, and now I'll fly through the stars very quickly. Because every 100 I go, I'll be traveling 100,000 units relative in the star field. Or maybe it'll just... I'm not sure what just happened. Did not like me setting it at 100 though. I do kind of want to see what happens when I get close to this. Come on, come on. And then what I can do is, as I travel this, we'll load stars in on the periphery and stream them into the data model whenever the player like changes. So like if I was in this system and I fly far enough to trigger a reorigin, then at that point I can recalculate the edge stars, add them to the set, and re-render everything. There's still some patterning here. Something's up. Oh, what's this guy? Okay. So wasn't happy with 100. And it's kind of funny because like what I'm using it for right now is the ability to rapidly traverse the star field, but what it actually is going to be used for is slowing it down. So like and that's where the real test comes into play. Scene units, so distance scalar, it's 100,000. So let's say it was only 1,000. Actually, let's leave it 100,000. Or actually, we'll do 1,000, but we're gonna make it feel like 100,000. And we're gonna change the size scalar to be like 50. So now I do this. We got a star field. But even though the star field's only 1,000, I move through it very slowly, which is exactly what I want to happen. Okay, I need to add some throttling here. Throttle event tick UE5.
Hello fellow Unreal Engine games developers. Today in this tutorial I'm going to show you 5 hints and tips for using event tick, either to increase the performance or to avoid the use of it. And you can see each event tick. So let's just print that out, and then get a second, and you can greater than 200. It activates if it 20 the initialized movement effect by event, and we'll connect this to the check here, and this. And once you've deactivated, you don't need to deactivate again. The next event you're going to be doing is activating frames per second. If I multiply that by the 3 degrees, it means that I'm doing 1 full rotation every.
I want a timer, and I want to do this calculation every 5 seconds and actually do like a transition. Timer. No, that's not it.
So every frame I'm going to check the velocity of my character, and then I'm going to do this print string as well here, so you can see what happens. Activating. So I need to attach this to a timer. So let's create another custom event. We want activating, it's only checking twice a second, and when I reduce 200 was by 10 or 10% each time.
Give logic every in timeout E5. Every execute logic, executing every second.
Alright, so what you want to do is hold on the keyboard and left click to create an event. And from that, create a timer. Set the timer. And it's time 1 second, meaning it will fire off every 1 second. And a custom event.
Timer.
copy it from there to the function name, and then add. Whatever you want to do every 1 second, and compile and play. Pressing play automatically compiles it, see?
Oops.
Close off every, and then add whatever you want to do every 1 second, and compile and play.
Does that work? Yes. So now you can kind of see what it's doing in real time. Okay, so how do we do this? Um, transition over time. UE5. Transition from one position to another UE5. 285 animate, move to position. Into location with animation. Move to. A challenge. So next is going to be figuring out like a way to smooth this out. Because like the thing is, like, we're making progress here. Okay, so like for instance, let's take a look at this guy, right? I'm going to move towards this guy, and we'll just gradually get closer and closer to it. Alright, so go back here. Change this again. Come on, come on, come on. Alright, so maybe it goes on the event loop. Gotta figure out how to do. Okay, there we go. Doesn't super help that I'm on like the slowest mode, but you can see that we're moving. I think that it needs to be a part of the, like, rather than get rid of this. Set location. I think it has to be edit project settings. Default pawn can be test pawn. DB5 set default player pawn. Player start. Okay, get rid of this. Go to okay, well, I'll just copy the shit from my other one. What up, dude? Trying to figure some shit out. We got this that we worked on earlier. And I can kind of show what that is. Maybe. Oh, maybe not. Or maybe it's all fucked right now because of the other stuff I was doing. Okay, it's all fucked. Get rid of this, get rid of this, get rid of this, get rid of this. How do I get that? I'm gonna open my other project and grab it from there. Go. Space, kind of game mode. Migrate. Oh, it's so much though, man. I don't want that. It's too much. Data only blueprint. Why is it accelerating now? Interesting. Oh, right, because it was... I know why. Alright. Well, now it's too slow for me to really perceive. 1,000 to... Should go faster now. There we go. I mean, it's really not that bad. And I don't see it flickering too much either. So maybe it just does go on the event loop. Fuck it. Date Starfield location. Now, thinking. So I kind of want to open my, hang on, close this one. Don't save. Save all this one. And go lift my pawn game mode from the other one, from the other project, so that we can start flying around this shit. Universe randomization core. Need to open Unreal 5 again. This time we'll take Universe project. I'm quite happy with the effect of using the color to pass in dynamic material parameters to a Niagara system. Oh yeah, man, migrate that shit to 5, man. What you doing? Pawns. Game instance. Universe game instance. Game mode. Game ship. Thruster ship pawn. Ship thruster. Asset actions. Migrate. Warp emissive, warp emissive, warp bubble, warp wrapper, warp. Okay, sure. And that's gonna go to UE5 Universe Sim content. Yes. All right, let's try it. Did it work? Content. Oh, you know what? It probably... Nope. Did it? Okay, so it just didn't work, I guess. PP game ship. Okay, this is the game mode. So I want to asset actions. I want to migrate this action. Yep. Okay. Universe sim content. So okay. Migrate. Okay. Content. How about here? Select folder. No. Content. Select folder. Migrating into a, would you migrate all into a folder with consolidated references? No. Copied 11 files. Okay, sure. Content. This is window, edit, project settings, game mode. Okay. Did it work? Please work, please work, please work, please work, please work. Seems like maybe it did. Oh, none of my input bindings are there, but I've got the, like, okay, that's easy. Window, edit, project settings, input. Can I copy this? Window, project setting, or edit, project settings. Access bindings. What? Engine input. All right, there we go. Action mappings. Left shift. Non-zero. Oh, okay. Two. Spacebar and left control. Okay. No. Pitch. Yeah. X 1 full E and Q. One. Looks good. Maybe we get some control now. Yep, we do. All right, so now that we have some actual speed, we can try some shit. Starfield is here. I want this. Yeah, we definitely want this to be much bigger. All right, so now it's only going to be a few 100,000 kilometers, but okay, let's try it. Let's see if it worked. So there's definitely some odd behavior, right? But the math is right. I just have to figure out the, like, clearly, like, because we're going so fast, it's causing all kinds of glitchiness, you know? And I think the way we actually do that is to attach Okay. Next thing I'm gonna try. We have thruster ship pawn here. Yep. I want to put a Starfield on this. Attach the capsule. And then I want to change the way this works to at local offs. Local station. Maybe compile, then delete this and go. Okay, that didn't work. Wait, did I not add it? I thought I added it. Mobility, movable, parent socket, none. Okay, let's try it. The fact that it's taking some time is a good sign. Okay, couple things. Thruster ship pawn. Delete this. Warp bubble. Save pile. Huh. What about like this? Huh? How about that? Capsule has to have simulate physics enabled if you like to use it to add force. Okay, we can fix that. Starfield here. Thruster ship pawn. Player start. 0, 0, 0, 0. Go. Okay. I think we just rapidly go out of bounds, so I don't even remember how to do this. Enable UE5, enable large worlds. Hello. Can I? Oh, might be locking up here. There we go. Maybe? Free up video memory, perhaps? Oh man, this is all kinds of fucked up. Oh, I'm back. Alright. Recovered. So I wanted to see it also moves with me on rotation, which it can't do that either. It's got to have its own. Huh. Bind position but not rotation to parent. Here at position but not rotation. Transform rotation type. Locations relative. Like that. And then like this. Okay. Seems like that's working. Alright, now I need to enable large worlds. UE5 enable large world coordinates. Go. System properties. Okay, so edit, project settings, world, support large world coordinates.
Before you start noticing issues. So we're going to be settings you can. I would. As you can see, once you get close to the border that was previously set in Unreal Engine 4, you start noticing some instability in the physics, maybe the graphics. So, for example, for me, that we've been using in Unreal Engine 4, this gives us 64-bit, which doesn't sound like a huge increase if you don't know much about programming. But basically what this means is every variable is that much more precise. Call it every little while the actual graphics would act up. So sort of shaders and things would kind of bug out. But with this, it's significantly more improved and much easier. So even if you do end up shifting the world origin point, then you can do it with this, and it'll. So we're going to show real quick how to implement that, as well as we're going to go over the performance differences. I'm going to show you 2 videos, one of which is going to be sped up for time. Basically, it's going to be how far away you can get before you start noticing these same issues. So let's go ahead and start off here. So what you're going to want to do upon loading in Unreal Engine 5, now this is an actual project, this is my own personal game, which you can check out my dev logs for. But this is my own personal game, so you can get a real world sort of look at how this sort of system works. So as it is right now, as you can see here, this is a real game. So what you want to do is, you may not have this setting here, so make sure to close it. A lot of times when I upgraded to Unreal Engine 5, a lot of windows got closed. I don't know about the default, but I moved from 4.27 to 5, so a lot of windows weren't quite open, at least the way I had them previously. So what you want to do to actually get to the setting is you want to come up here to Window, and you're going to come all the way down here to World Settings, and this is where all of your settings for baking, lighting, and everything all sit, as well as some level options as well. And then in here, you're going to want to scroll all the way down to, you'll see a tab labeled World, and in here you'll see Enable Large Worlds. Now, according to them, this is the alternative to actually
there it is.
setting a large
That's what I was
world
looking for.
max. This is technically not considered stable in that this is not the correct alternative. What they actually recommend is, if you go to the documentation, there's actually explicit settings you can set in your C++ code labeled World Max and then Enable Large Worlds. These allow you to set more of an exact distance. They said that, I believe by default, let's see here, yeah, so if you don't select this option by default, and when you click it, yes, it is set to 21 kilometers.
And then we just stream more into the boundary as we cross the distance.
So use UE4 World Max set to 0, so you're not using the World Max anymore, which means that this will actually set the World Max volume value to approximately 88 million kilometers, according to the documentation. I found that, at least in actual terms of use, that Enable Large Worlds right here is just fine. You'll see just as good a performance. It's actually going in and manually setting, and this is a heck of a lot easier. Now, of course, this comes with stability, so if you're an indie developer, definitely go ahead and check marks it. But if you were, working in a AAA studio, which if you, I don't know why you're watching these videos, but on the off chance you are, I would recommend using this. There's more stable options. So let's go ahead and take a look here. So with my current game, it is a space game. This is sort of where Unreal Engine is going to be able to leverage this large world.
Alright, so that's great, and now what's really cool is that we can go to VP Starfield.
Thanks to this new update, I'll make sure to push these even further away so I can make it a little bit.
Can you believe it? That's all it takes. That's all it takes right there. And then
far away, you will start to notice some instability, and I'm going to start showing you 2 videos right here sped up. I believe the short one is about 2 minutes long, but I'm actually going to cut it off and stop it.
so here it is on 10,000. We should be 10 times slower to go between stars.
But as you can see, once you get close to the border that was previously set in Unreal Engine 4, you start noticing some instability in the physics, maybe the graphics. So for example, for me, it's mostly the graphics. So as you get far enough away, and I'll actually have the actual distance I traveled in Unreal Engine units down below each of the videos. But as you get far enough away from the actual origin point, not from where you spawn your character, your ship, but the actual origin point of the world, so the 0, 0, 0, you'll notice instability. And what this large world does is it actually gives you a 64-bit double precision. What do they call it? It's just called a double precision data variant types. So basically what this means, instead of the normal 32-bit that we've been using in Unreal Engine 4, this gives us 64-bit, which doesn't sound like a huge increase if you don't know much about programming. But basically what this means is every variable is that much more precise. So even when you get really far away, it allows for all of the placement and origins and rotations of all objects to be much more precise, which is extremely handy for long distances, because as you get further away, as numbers get higher, you can end up with what is known as, what do they call it? Actual software engineering. I should know this, software engineering. But essentially you go over the maximum limit, my brain's a little fried today. You go over the maximum limit of that actual data type, and you'll end up getting, overflow errors and things like that.
The positioning.
And as you can see, this video on the right hand over here, your right hand, my left hand, was sped up to match this video, and it is significantly farther here. I'm going to have the actual numbers here. I don't have them right in front of me because I need to actually edit those videos to sync them up. But it's significantly farther before there's even a slight amount of instability. And from what I can tell, the instability is actually mostly with the physics side, not with the graphical side, which was actually an issue when it was before. It was more graphics side. The physics would be fine for a little while, but the actual graphics would act up. So sort of shading some things would kind of bug out. But with this, it's significantly more improved. And from what I understand, there are some tweaks that you can do.
Does that get rid of the gutters?
So that you can
Not really. There's still this one.
which is a little tougher. But for those of you who want an even bigger world, this just basically makes that so much easier. So even if you do end up shifting the world origin point, you can do it with this, and it'll extend how long you can go before you ship.
Alright, so now
I believe that is it.
we go and we make.
If you have any other questions, you want to subscribe, definitely go ahead and do that below. I am still taking names for ships, so if anyone wants a ship named after them, make sure to leave a comment down below what you'd like the ship's name to be. But otherwise,
10
good luck
million.
and good hunting.
Now it just, like, you would have to actually go very quickly to get to any of these. So let's try it. Accelerating. Well, okay. So maybe that's a little bit much. 10 million, not too much in the game. It would actually be more than that. But for the purposes here, before we have warp speed in place, a bit too much. Randomizer functions, coordinate randomization core. BB Starfield, here it is. I did 2 million for this. Let's do 1 million. I know that was a million. Do 100,000. What's the distance scalar? 1,000. So we could increase this to 10,000. And we can increase the size scalar to 500. All right. Hammer the gas. One thing I want to try, Starfield. So if if we have 80 million kilometers to work with, and we are 40 wide, or 80, that means the distance scalar should be 1,000,000. Okay, that's going to space it across our entire usable space. And then that's where we can have the thousand. So now every time we go 10,000, we should transit 1,000,000 through the star field. I must just be going really slow, or something is not working the way that I think it does. How is that ever working? I'm confused. Well, I guess I was just traveling through it. Okay, I see. It wasn't doing anything. Was the issue? There we go, that's more like it. Alright, so this should be 1-to-1. With my speed. This is fine. Starfield. Okay. Player offset. Don't worry about that. $100,000, million, 10 million. Distance scalar is at 1,000,000. Let's do parity first. Alright, so this is moving at the speed my ship's actually moving. In units. Okay, so one thing that needs to happen for sure is in my actual Gara, in the position where we calculate the sizes. This. Copy this, add vector 2, paste, point 2, or point, yeah, that's fine. Alright, save that. So we have a minimum size on those. And then Starfield. Now we're going to start going big here. 10 million. Let's go. And then basically, as I enter the proximity of these stars, you would sub out the actual solar system shit centered on it. so that's how fast it looks at 10 million. But what we would really be looking at would be more like 80 million. Alright, so if I run this, this is how fast the ship actually is in space in like interstellar travel. So pick a star, start heading towards it. I mean, we're moving a little bit. I need to turn off all the arrows from being visible. I mean, I'm definitely moving. And this is about what you want. Like, it should be nigh imperceptible. This is... And you kind of just have to tell with relativistic motion, like, which star is the closest to you. Like, can I ever get there? I'm definitely getting a little bit of parallax and shit, so like it is working. I'm curious at what my location is after all this transiting. Probably quite far away. I mean, that's pretty cool. It's like an interstellar journey just happened. It works. It works. At least this part of it. So the next piece of this is rebasing. So basically, also that exposure setting is trash. But we have to, like, every time the user goes from like 80 million to every time the user basically passes a threshold in the coordinate systems, negative 80 to 80 million, positive 80 million on any of the axes, we have to then recalculate the edge stars, feed those into our array. We have to rebase the origin to where the user is with relationship to the new system they've entered. And we have to spawn the new system on top of the grid space particle. So there's still a lot to do, but this is definitely a proof of concept here that what I wanted to do as far as like, so like here's the fun part of this right now. So we just went 80 million kilometers or units, I guess, to transit between the distance of basically between one star. So let's go ahead and cut this down just to like 20 million, just so that we can get a little bit faster feedback. But then here's the fun part. This is at 1 million. About 100,000. will this work? So this should transit the same speed. Or not the same speed. But like right now, we're traveling very, 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 very fast relative to the scale of this. Like these are only like 100,000 away from each other, and we're going millions of units. You could also, if you wanted to, I think that it actually does look better with them at the 1 million units away from each other, but maybe I don't want, so million, 20 million, I should transit the same speed we were just seeing. The stars themselves will be further apart, so they'll look different. Feels about the same. Oh yeah, that's sick. I'm gonna fix this right now. BP ship thruster. Visible. Nope. 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 Will this help some of my flickering effects? I wonder. Hey, it fixes the flickering on my ship thrusters. That's great. Alright, so what if what happens, now it's just like fun experiment time. Scene units to universe, so what happens if my distance scalar is actually 10 million, and we go up another order magnitude on size? Maybe like 5 times as big. 10 million, 5 times as big. We'll transit that 10 million every 1 million units. Seems to work just fine. Except for the banding here. I gotta figure that out still. So I think that what it's probably going to end up being is something along the lines of 1 million. That stretches out to about 80 million kilometers. And then the scene units to universe units. $80 million. Okay, so with this right here, I have my static Starfield that is also enabled for interstellar travel. There's stuff I gotta tune, clearly, but with this, we can do no load screen, interstellar travel. This is one piece of the puzzle. I also need the reorigining is left to do still. So that's going to be a challenge. The streaming of in the background of more scans around the periphery of the visible space to bring things in to visibility as I get closer. That's got to be done. And the level of detail-ish swapping around of the solar system to match, to overlap the nearest star, basically. Whatever star you're closest to, that will be the star that has the solar system rendered, and then, or like the actual subcomponents generated. And then whenever you transition from being closest to that star to being closest to another star, we'll dispose that, generate another one, etc., etc. It does this job pretty effectively of like, it's almost can't tell that you're moving except for the like relativistic like parallax motion you get on some of the close-up stars. This is a big star. Hey. Okay. I gotta. I hear my dog's getting into something. I'll be. Actually, won't be right back. This is a good stopping point for the night. Made a lot of progress today, considering we re-arced the project. So, later, guys.